Hello and welcome to another Algebra 1 lesson by eMath Instruction. My name is Kirk Weiler and today we'll be doing Unit 1, Lesson 12 on algebraic puzzles. This is the final lesson in our Unit 1 and the algebraic puzzles that we'll be looking at are going to combine a lot of the different skills that we've used or learned throughout this unit. This is a little bit of a challenging lesson. We're going to be working with a lot of kind of complicated English phrases that we're going to want to translate into mathematical like expressions, but we can do it, right? So let's take a look at some algebraic puzzles. All right, patterns. One of the primary uses of algebra is to understand patterns that occur. As we work on this, be mindful, right? Mindful manipulations. Be mindful in the algebraic manipulations you use to understand the patterns. Let's take a look at exercise number 1. Choose any number. Create the sum of 2 more than 3 times the number with 2 less than 2 times the number. What pattern is true of the result? Letter A. Let us explore the pattern with numbers we know before working with algebraic expressions. Even using numbers, the English is a bit tricky to decipher. First, do the manipulation together using a single number. Let the number we choose be 3. Show the calculation as described in the problem. Okay, so I'd like you to actually take a shot at doing the calculation, given that kind of phrasing in italics up there, just with the number 3 and see what you get, and then we'll go through it. Pause the video and see what you can get. All right, well, let's start with 2 more than 3 times the number. Well, what's our number? Our number is 3, so 2 more than 3 times the number. Well, 3 times the number is going to be 3 times 3, and 2 more of it's going to be 2. So that's going to be 9 plus 2, and that's going to be 11, right? And we want to add that, right? We're looking at the sum of that with 2 less than 2 times the number. Well, 2 times the number, right? And 2 less than it. That's going to be 6 minus 2. That's going to be 4. I want to add those 2 together. 11 plus 4 is equal, to 15. All right, so when the original number was 3, what we got from doing this manipulation was 15. And what we'd like to do is do this with a bunch of numbers and see if there's a pattern. And if there is a pattern, we'd then like to try to prove that pattern algebraically. All right, so let's take a look at letter B. Okay, now let us set up a table using various values to see if we can find a pattern. All right, and let's try to kind of put these calculations all together. And why don't we put down the calculation when we had 3, right, and get that result of 15. That'll be like one of our numbers. So when our number was 3, right, remember we had 3 times the number plus 2 plus 2 times the number minus 2, right? That gave us our, our 9 plus 2 plus 6 minus 2, and that ultimately gave us 9 and 2 is 11 plus 6 is 17 minus 2 was 15, right? So keep in mind, right, we had 2 more than 3 times the number plus 2 less than 2 times the number, and when our number was 3, our result was 15. What I'd like you to do now is grab 3 additional numbers, right? 1, 2, 3. In theory, it could be any numbers you want. Go through the calculations, see what the result is that you get, and then compare the result to the original number and see if you notice a pattern. Pause the video now and go ahead and do that. All right, well again, I don't know what numbers you picked, so I'm just going to grab some random numbers. I'm going to keep them relatively small so that we don't have to think too hard about the calculations. Maybe I'll go with the number 5 next. Again, I want 2 more than 3 times the number, so that's going to be 3 times 5 plus 2. I'm going to add that to 2 less than 2 times the number. That's going to be 2 times 5 minus 2. So 3 times 5 is 15, plus 2 is 17. I'll do that calculation all at once. Plus 2 times 5 is 10, minus 2 is going to be 8. 17 plus 8 is 25. So the result is 25. So when I started with 5, my end result was 25. When I started with 3, my end result was 15. Let me go with, we did a couple odds. Let me go with an even. Let me go with 8. All right. If I use 8, I'll have 3 times 8 plus 2, right? 2 more than 3 times the number, summed with 2 less than 2 times the number. 3 times 8 is 24, plus 2 is 26. 2 times 8 is 16, minus 2 is 14, right? So what I will get there is 40. All right, so when I started with 8, the result was 40. All right, one more number. I don't know, let me go with 11. You know, I've been going even, odd, go back to odds. Let's see, I'll get 3 times 11 plus 2 times 11 minus 2. 3 times 11 is 33 plus 2 is 35. 2 times 11 is 22 minus 2 is 19. No, sorry, 22 minus 2 is 20. And that's going to be 55. All right. So what's the pattern? Pause the video now, and regardless of whether you're looking at my results or your results, right? What is the pattern? What's happening to our number to ultimately get the result? All right, well, I'm hoping you see it. 3 gives us 15, 5 gives us 25, 8 gives us 40, 11 gives us 55. Each one of these results is 5 times the original number, right? So the pattern was 5 times n, or 5 times the original. All right, so now, how do we prove that? Let's take a look at letter C. Now, let us prove that the result you see in the table will always be true. Let the original number now be called n. Write an expression that translates the verbal description given in the problem for our calculation. Okay, so remember, right, the first thing was that we had a number we were going to sum, right, 2 more than 3 times our number with 2 less than 2 times our number. Well, right, here is 2 more than 3 times our number, right, 3n plus 2. And we wanted to add that to 2 less than 2 times our number. And that's that, right? So this is just translating the pattern that was given to us in words into a mathematical expression. Because of the associative and commutative properties of addition now, I can rewrite this as 3n plus 2 plus 2n minus 2. I can flip-flop the order of this using the commutative property of addition, 3n plus 2n plus 2 minus 2. 3n plus 2n I can now combine, right? I can use the associative property of addition like this. 3n and 2n is 5n, 2 minus 2 is 0, and 0 added to anything doesn't change it. And there it is, right? If our original number was n, our result will always be 5n, which is 5 times the original number. That's not obvious when we first look at the phrasing of the problem. But as we develop the evidence using numerical examples and then prove it using our algebraic proof, it's clear. Let's take a look at another pattern. All right. Or let's take a look at a fairly simplistic multiple choice problem. Exercise number 2. This is a fluency problem. If n represents a number, which of the following expressions represents the sum of 1 more than twice the number and 3 less than 5 times the number? All right, so why don't you see if you can figure out what phrase, what algebraic expression represents that description. Pause the video now. All right, well, again, we've got a sum, so an addition, of 1 more than twice the number, That's going to be 2n plus 1 plus 3 less than 5 times the number. 5 times the number will be 5n. 3 less than it will be minus 3. Just like before, we can get rid of those parentheses due to the associative property of addition. We can use the commutative property then to rewrite this as 2n plus 5n plus 1 minus 3. Again, a little bit of associative property here gives us 7n minus 2. Choice 1, right? So we want to be able to translate those very complicated phrases into expressions so that we can then see patterns that come out of the expressions. All right, let's take a look at a complicated one that also has a product in it. Now, we should be watchful for products that are involved in these types of problems and patterns, especially because the distributive property can easily come into play, right? The distributive property is when you're multiplying something that's within a parenthesis by something outside of a parenthesis, and you distribute that multiplication through. Let's take a look at exercise number 3. In this problem, we will explore a calculation of the difference between the product of a number and a number 5 larger than it, and the product of the same number and a number 5 less than it. Will this reveal a pattern like the last one? Like before, in letter A, we want to first explore the pattern with numbers that you know before working with algebraic expressions. So let's let the number we choose be 10. Show the calculation described in the problem. And again, this is an even more complicated calculation than what we saw before. So I want you to pause the video, start with the number 10, and see if you can figure this out. The difference between the product of a number, that number being 10, and a number 5 larger than it, and the product of a number and a number 5 less than it. All right, so pause the video now and see if you can just work it out when the number is 10. All right, well first, right, we got this difference, so it's a subtraction, but let's worry about that a little bit later. You know, the first thing we've got this product, right? And we've got the product of the number and a number 5 larger than it, right? And then that's going to be 10 times 15, and that's 150. Right? And then we've got the product of the number and a number 5 less than it. So that's going to be 10 times 5, and that's 50. And then we're going to find the difference between those two, and that's going to be 150 minus 50, and that's going to be 100. Okay, so when I started with the number 10, my pattern gave me 100. But that's only one number, you know, so I'm not sure. Maybe the pattern is I'm squaring it. You know, maybe every time I'm just going to kind of get this number, and I'm going to square it, and I'm going to get that number. You know, 10 times 10 is 100. Great. But I don't know. So maybe I should work this out and see if I can kind of find out, you know, if there's a larger pattern here. Maybe there's no pattern at all. Doubtful. So I'd like you to pause the video. We're going to maybe put in the number 10 here. Actually, let's do that right away, and then we'll have you do the other ones. And let's kind of, again, do it as this like full calculation, right? I've got 10 times 10 plus 5. That's the product of the number with 5 more than it. Minus 10 times 10 minus 5, right? And as I saw, that was 150 minus 50, which gave me 100. Okay, so what I'd like you to do now is pick 3 other numbers, fill in the calculation and the result, and see if you can develop a pattern. Pause the video now. All right, well, you know, again, if you want to avoid negatives, right, or avoid them as much as you can, then the only place that I'm really going to be worried about them is when I take the number and I subtract 5. So if I choose any number that is less than 5, more negatives are going to be involved than maybe you need, but again, the pattern should still hold. I'm going to stick with numbers larger than 5 so I don't run into that issue. And actually, let me go with the number 6, right? That's kind of nice. So if I have the number 6, right, again, I want the product of 6 with 5 more than 6, minus 6 with 5 less than 6. All right, here I'll have 6 times 11. That's going to be 66. And then 6 times 1, which is just 6. 66 minus 6 is 60. And so that's the pattern I get when the number is 6. All right, I can just keep doing this. Let me go with an odd number. Let me go with 9. I like 9, right? So here I'll have 9 times 9 plus 5 minus 9 times 9 minus 5. So here I'll have 9 times 14. 9 times 14 is 9 times 10, which is 90, plus 36, it's 126. I think so. And then 9 times 4 is 36. That one I know off the top of my head, and that'll be 90. So when I start with 9, I get 90. Okay? And let's do one more. Actually, forget about it. I'm going to go with a number less than 5. Whatever. I'm going to go with the number 2. Let's get some negatives involved. All right, so I changed my mind already. So I'll have 2 times 2 plus 5 minus 2 times 2 minus 5. I'm going to put some extra calculations in here. 2 times 7 is 14 minus 2 times negative 3. So that's going to be 14 plus 6, and that's 20. All right. I wanted to put this extra calculation in here because I didn't want to be so quick about saying, well, I've got 14 minus negative 6, right? Just because we're still working out the kinks with subtracting negatives, I think, at this point in our mathematical careers. So what's the pattern? It's probably pretty obvious here, but pause the video and see if you can write something down. All right, well, it sure looks like whatever number I start with, my result is 10 times that number. All right? Looks like it. All right, 10 times the, starting number. Magic red pen. 10 times the starting number. Okay. Let's see if we can prove it. Letter C. Now prove that the result you see in the table will always be true. Let the number now be called x, just because, n has gotten enough work. Write an expression that translates the verbal description given in the problem for our calculation. Okay, so you're starting with x, and what you hope to have at the end of this is 10 times x, or 10x. See if you can play around with it and produce that as your final solution. All right, well, let's get some basics, right? We've got our number x, we've got our number that's 5 more than x, we've got our number that's 5 less than x, right? We knew that we had a product of the number with a number 5 larger than it, right? And then we were going to subtract off the product of the number with the number 5 less than it. So that's kind of where we start, right? That is our basic pattern. And in fact, if you looked back at our table and you looked at all of these calculations going on up here, every single one of them has exactly the same structure as this does, but instead of having x, right, we have whatever particular number we started with. Now let's do some algebraic manipulation. Here's where our distributive property is going to come in. We're going to multiply both of these by x. We're going to get x squared plus 5x. Now watch out here. We've got a subtraction. So I'm really multiplying through by a negative x. So negative x times positive x is negative x squared. And negative x times negative 5, a negative times a negative is a positive. And we get positive 5x. All right, that almost looks like I should get 0, right? But keep in mind, this is x squared plus 5x plus negative x squared plus 5x, right? So we can actually rearrange this now as x squared minus x squared plus 5x plus 5x. X squared minus x squared, that's just 0. 5x plus 5x gives me 10x. And there you have it. We could have started with any number we wanted. We could have started with the number pi, right? 3.1415, etc., a nice irrational number, and we would have gotten 10 times pi, 31.41, whatever, you know. So it wouldn't matter. This has proven that whatever we start with, that description will always give us 10 times where we started. And we know that by using algebraic manipulation. Let's wrap this up. There wasn't particularly anything new in what we did today. There wasn't, right? We were translating verbal phrases into algebraic expressions. We were understanding what those phrases really told us, products, sums, differences, etc., right? And then we were using algebraic manipulations, things that involve the distributive property, the associative and commutative properties, right? And we did all of that in order to prove particular patterns that we observed using numbers would always hold by using variables or unknown numbers instead. These are great skills to kind of reinforce throughout the problems on the homework. Some of them are going to be quite challenging. Keep at them, right? Keep at them. You'll be able to get through them. All right, I just want to thank you for joining me throughout this entire unit, right? We're going to get into Unit 2. Next unit, we're going to start solving equations and really getting into the meat of algebra. For now, though, I want to thank you for joining me. My name is Kirk Weiler, and until I see you next time, keep thinking and keep solving problems.